Hello guys, welcome back to my channel. Here we have a very interesting question. We have to evaluate this added to 2, the whole of this plus 2. Of course, you know all these are iota raised to various high powers, okay? And we have it at the numerator and then the denominator. So how do we evaluate this in order to arrive at an answer? So that is the purpose of this video. If you are ready, let's get started. So we have a solution. So here, what we're going to do is that first I need to lay some foundation, okay, when it comes to evaluating I. Of course, we know I represents what I represents. I represents minus, square root of minus 1. So that is what I represents. So if I is square root of minus 1, what then will be the value of I squared? This will simply be the square of minus 1, which in turn will give us minus 1. Alright, so if I squared is minus 1, what then will be the value of I to the power of 3? So this will simply be I squared dot I. Of course, I squared is minus 1. I is square root of minus 1. Which we can also just represent as I. So this will mean minus 1 times I, which means minus I. What about I to the power of 4? This is the same thing as saying I squared to the power of 2. I squared is minus 1. Then when you square that, we are going to get 1. So this is very important in tackling this problem because I to the power of 4 is 1. What about when we have powers that are multiples of 4? Like, for example, I to the power of 8. This is the same thing as I to the power of 4 to the power of 2. I to the power of 4 is 1. And then when you square that, you are going to get 1 as well. So let's say we look for I to the power of 12. The same thing, that will be I to the power of 4 or to the power of 3, which is the same as 1 to the power of 3, which will give us 1. And I can go on and on and say, for example, I to the power of 20. Of course, this is the same as I to the power of 4 or to the power of 5. I to the power of 4 is 1. And then when you raise that to the power of 5, the answer is 1. What about if we have I to the power of 100? What would that give us? That would give us I to the power of 4 times 25. I to the power of 4 is 1. 1 to the power of 25 is 1. So we can go on and say, for example, I to the power of 3000. 3000 is actually I to the power of 4 multiplied by 750. Because I to the power of 4 is always 1. And then to the power of 750, that will still give us 1. So as long as the power of I is a multiple of 4, the result is the same thing as I to the power of 4. And that is, this I to the power of 4 is going to be very crucial when we evaluate this. And there's something also I need to say, although that may not really be relevant, but let me just say it. If I have, for example, I to the power of 1 plus I squared plus I to the power of 3 plus I to the power of 4, this is actually equal to 0. What that means is that, of course, you know what this means. This is square root of minus 1 plus minus 1. Of course, this is plus minus I. And then, of course, we have a plus 1. This and this will go. And then, of course, you have this and this are the same. So the result is 0. So this is very important. In terms of when you have consecutive powers of the iota, that gives us 0, alright? So how do we now evaluate this? Very easy. So what I'm going to do now is to come over here and say, first I will need to look for if we have common factors at the numerator and the denominator. There is a common factor, and the lowest power there will actually give us a common factor. So we have I to the power of 584 times, the whole of this will reduce down to I to the power of 8 plus I to the power of 6 plus I to the power of 4 plus I to the power of 2. Then we have plus 1 divided by, same thing happens at the denominator. I'm going to factor that out. Factor out 574. Then inside the bracket you have I to the power of 8 plus I to the power of 6 plus I to the power of 4 plus I to the power of 2, then plus 1. All of these now will be added to 2. Okay, so from there, you can see that the brackets contain the same terms. So they can actually cancel out each other. So we have now I to the power of 584 all over I to the power of 574 plus 2. And then I'm going to apply this rule of indices that if I have a to the power of n over a to the power of n, this is the same as a to the power of n minus n. So I will use this rule to evaluate what we have here. So I will use this rule to evaluate what we have here. So that will be I to the power of 584 minus 574 plus 2. Alright? So that will give us, let me come over here. So here I will have, so 584 minus 574, that will give us with I to the power of 10 plus 2. I to the power of 10 is the same thing as I to the power of 8. Okay, no, I to the power of 8 times I to the power of 2. Then plus 2. I to the power of 8, like I said earlier, any power that's a consecutive, that's a multiple of 4. When you have I, and then the power is a multiple of 4, that is 1. Multiplied by I squared is minus 1, then plus 2. So when this multiply, you have minus 1 plus 2. So the answer here is 1. So guys, there you have it. Don't forget to subscribe if you have not done so. If you are a returning subscriber, please watch, learn, of course, share and then comment, and then I will see you in the next video. Thank you and God bless.